Hello everyone. So today we will start solving examples on multithreading. So first I'll create a class. Let's call it main. Main class. Let's see our tasks. So the first task is to start a thread. So create a class that extends thread. In the run method, have the thread print thread started and sleep for a second, then print thread completed. So thread is the smallest unit of execution in a program, right? So we will create, let's say, thread example extends thread. So to create a thread, we can extend the class thread and let's create an entry point to our program, extend the class thread, then we can run our thread using the method start. So first let's create a thread. So let's create an instance of class thread. Thread example, let's call it thread, new thread example. And in order to be able to use our thread, to be able to run the thread, we need to override the method run. So let's override method run. So this is override. Let me add this override. So we want to print out the message. Oops. I want to print out thread started. Then we'll try to put our thread to sleep. Use try catch block because it can throw an exception. So we try to put our thread to sleep. So sleep allows us to pause the activity of the thread for a given time, so for 1000 milliseconds, which is 1 second. Then we catch the interrupted exception and let's print some stack trace. Alright. And we are done. Right now also we want to print out message thread completed. Right, thread completed. So we wait 1 second, then we print out another message thread completed. All right. So we created an instance of class thread example. So thread example, it inherited the method start from the class thread, so we can call thread.start and we can run our program now. So thread started, then after 1 second it printed out thread completed. Alright. Now let's move to the next task. Create a class that implements runnable and pass it to thread in the run method and print runnable is running. So runnable is a functional interface. Now let's create a new class, runnable example. So implements runnable. So we need to implement the interface the difference between a runnable and a thread is that runnable is an interface, so we can implement as many interfaces as we want, and also we need to override the method run. So public void run. Now what do we want? We want to print runnable is running, so we want to print out runnable is running. Okay, now let's go to our main method, and so here let's create an instance of class runnable. Runnable example, let's say runnable new runnable example. Now in order to be able to run our thread, to start the execution of our thread, we need to create an instance of class thread. So thread new thread, and we need to pass our task. So runnable is our task that we want to perform on our thread. So we created our thread here, and now we need to pass the task itself. So that is the difference between thread and the implementation of interface runnable. Now we can run our thread using the start method. So it should print out runnable is running, and it finished the execution. Alright, the next task is to start 5 threads, each printing its name using this construction and sleeping for a random amount of time from 1 to 3 seconds. So let's create a new class. Let's call it multiple threads. Okay. So we want to start 5 threads, each printing its name. Okay. Let's create a main method, main. So to do this, we can either use the executor service, or we can do it in the thread class itself. And let's use thread for now. So thread, new thread. Then we put our lambda expression within the constructor of the thread. So now what we want to do is that we want to start 5 threads, and so that each prints get name. Alright. So we print out we need to print out the name of the current thread, so we can do it using the thread.currentThread.getName method. So this will return the name of the current thread. And then we want to put that thread to sleep. So let's create a random, implement the random class. Let's call it a random, new random. And now let's declare a variable sleep time. So sleep time, then we'll take random. We want to have the sleep time between 1 and 3 seconds, so we make 1000 plus random dot next int. Let's put the bound 3 seconds, so it will be between 1000 and 3000. Of course, this is in milliseconds, which means that the bound, that sleep time will be between 1 and 3 seconds. So now let's write the try catch block for our sleep method. So try to put the thread to sleep. For the sleep time, that will be randomized. Then catch that and print stack trace. Alright, so this is for a single thread, but we want to have 5 threads, so we will put it in a for loop for integer I, which is equal to 0, I is less than 5, and I plus plus is our step. So now it will create us 5 threads, and each thread will print its name and sleep for a random time. Alright, now let's call our thread. So thread dot start. Let's run this. So as you can see, thread 0, 1, 2, 3, 4, so 5 threads were executed. So everything works correctly. Now let's move to the next task. We're asked to create 2 threads that print messages to the console. In the main thread, use join so that the main thread waits for both threads to finish before terminating. Okay, let's create a new class. Let me call it thread join. Alright, let's create a main method. So let's create a thread. Let's call it T1. New thread. Now let's implement our lambda expression. So we'll print out thread 1 started. Alright, then we'll put that thread to sleep. So try thread sleep for a second, then catch and print stack trace, and in the end we'll print out thread finished, thread 1 finished. Okay, let me take this and copy for our second thread and call it T2. So T2, and same logic here. And then we'll start our threads. So T1 start, T2 start, and put a try catch block for our joins. So T1 join, T2 join, and catch. Interrupted exception. Alright. And in the end we'll print out all threads have terminated. Like this. So now let's run this. So thread 1 started, thread 2 started, thread 1 finished, thread 2 finished, and all threads have terminated. Alright, so now our program works correctly, but what if we remove this joins then you will see the abnormal behavior of the program. So first it prints all threads have terminated, then it says thread 2 started, then it says thread 1 started, and you can see what's going on here. So that's why we use our joins, so that one thread waits for another. So thread 1 waits for thread 2 to start, then it finishes, and so they all finish at the same time. So when they finish, this message is printed to the console. Alright, now let's create a thread that executes an infinite loop. After starting the main thread, call interrupt after 3 seconds and make sure the thread finishes gracefully. Okay, let's create a new class. Let's call it interrupt. Am I right? Interrupt the thread. So let's extend the class thread. Okay, let's override the method run. So public void run. So let's print out. Let's first put our thread into infinite loop. So while true, print out infinite loop. Thread in infinite loop. Then we'll put our thread to sleep. So try thread dot sleep for a second. Catch the interrupted exception, and let's create an instance of class interrupted thread. Let's call thread new interrupted thread. Let's call thread dot start, and then let's try thread. Actually, thread dot interrupt, and we'll put our thread to join so that it finishes gracefully, it terminates gracefully. Alright. And we'll print out thread has terminated gracefully. Okay, let's run this. Let's see what we got. Oh, we got an infinite loop. Looks like our program is a little bit wrong. Alright. Let me remove this. Let's put this line in our thread. Interrupted. Actually, let me try this one more time. So it's still in the infinite loop. Let's try one more time. Okay. Okay. Let me take this and put it in the main methods. Let's remove this message and print out the thread has actually the thread was interrupted and terminated gracefully. Okay, so we start our thread. Then let's put our main thread to sleep for 3 seconds. Thread.sleep, so that it could terminate gracefully. Then we'll interrupt and print out the thread has terminated gracefully. Let's run this one more time. So let's actually remove this. This will be a main method, main thread. We'll print out this message and let's add a break. Now it should work. Let's try one more time. So main thread says the thread has terminated gracefully and the thread was interrupted and terminated gracefully. Okay. Next task is to create a thread that runs for 5 seconds, printing working every second. When finished, print thread terminated. Okay. Let's create a new class. Thread working. So let's create our thread. Let me implement the runnable interface this time. Runnable. Now we need to override the method run. So public void run. So what do? Now we write the logic behind our thread. So we say try a for loop for integer I starting from 0 up to 5, and the step is I++. And we want to print the message. Print the message working, then put it to sleep. So thread sleep for a second, then catch, interrupted exception, and we're done. And one more message. We'll print out thread terminated. right. Now let's create our main method. So runnable, it describes the task that needs to be performed. So now we need to create an actual thread. I mean, first we create an instance of class thread working. Let's say worker thread. It's called the constructor. Now we need to pass this worker thread to the actual thread. So thread, let's call it thread, new thread, and pass our worker thread and start. Now let's run this. So you can see working, and thread terminated. So the program works as expected. Now let's create a counter class that contains a count variable and an increment method that increments it by 1. Start two threads that call increment 1000 times and check if count is updated correctly. So this is a race condition problem. Let's create a new class. Let's call it a race condition problem. Alright. Create a main method, and let's create a counter class. So we're asked to create a counter class that contains a variable count and method increment. Alright, actually let's go down, class counter. So counter has a string count. Actually, this is an integer. Integer count. And method increment. So public void increment, and this increments the count, so count plus plus. Alright, now we need to call the increment 1000 times. Let's go to our main method. Let's create an instance of class counter. New counter. And what do? Now we need to create a thread. So thread T1, new thread, and the same for T2. Now we need to write the logic. Let's use lambda expression. So what do? We want to call the increment 1000 times. So for integer, let's actually use try block. So try for integer starting from I0, go up to 1000, and the step is 1. We want to call the method increment, so counter.increment. Alright, and do we print anything? No, we're not asked to print, just increment. then let's catch some exception. Let's call it exception. And we're done. Let me take the same logic for the second thread. Alright, so now we need to start our threads. Let's start our thread. So this should call a race condition. I mean, an error that occurs during when two threads are attempting to modify the shared resource. So in this case, they're both writing to the variable count, incrementing and writing to the variable count, and this can cause, I mean, this can lead to the incorrect result, so that we can check that. Let's run our threads. So T1 start, T2 start, and in the end, let's add a getter here. So public integer get count, return count. So we call counter.getCount. Alright, let's run this. So it is 0. Why is it 0? Maybe because we didn't initialize it. Counter.increment. Let's run it again. Still 0. Looks like we have a race condition. Let's try to make our threads to wait each other. So T1 join, T2 join, and we need to wrap it around the try catch constructor. So let's have a try catch. Now again, we should have an inconsistent incorrect result because our method increment is not synchronized. I just want to see the incorrect result. 2000, 2000. I guess we're lucky. You can see 1985. Race condition occurred in this case because we didn't specify the synchronized keyword. So keyword synchronized is a mechanism, a synchronization mechanism that allows us to control. So it allows only one thread at a time to access and modify a shared resource count. So now if we try to run this, it should always print 2000 no matter how many times we run this. So I run this again. It should always be 2000, as you can see. Alright, now let's go to the next task, modify the previous class and add synchronize. So that's what we did. I added synchronized here. I added synchronized to fix the race condition, and I made threads wait each other by using the join statement. Alright, now let's move the next one. Create a bank account class with a withdraw method that decreases the balance. Start 2 threads that try to withdraw money at the same time and use synchronized to avoid incorrect operations. So let's create a class bank account. Bank account. So we should have method withdraw. So let's create a method withdraw. Public let's first have a balance, or let's just create a method withdraw withdraw, am I right? Withdraw, yes. So it decrements the balance. Let's have some variable private string balance. Alright. So what withdraw does is that it decrements the balance. So balance let's say, why do I always put this string? This is an integer, it's a double, let's say double. And let's say we pass some double. Let's say amount. And we make balance minus equal the amount. And we're allowed to use synchronized, so let's use synchronized. And let me create a constructor so that we could add the initial balance. So public bank account double balance, and this balance is equal to the balance. Alright, now we're ready to go. Let's create an instance of class bank account. Say account, new bank account, and the balance, let's say $1,000. And let's make it more, let's make it 3,000. Alright, and now we need to create 2 threads. Start 2 threads that try to withdraw the money at the same time. So let's say thread T1, new thread, and thread T2, new thread, so they both should withdraw the money at the same time. How can we do this? Now let's write the logic of our threads. So this thread will take our account and withdraw, let's say 600. Alright, and let's give it a name. Let's call this thread 1, thread 1, thread 1, and the same logic for the second thread. So account dot withdraw, make 400. Let's call it thread 2. So thread 2. Let me modify our withdraw method, let's add some if statements. So our balance should not be less than 0. So if balance is less than, no, if balance is greater than or equal to amount, we will decrement the amount, and we'll print out, let me add a getter as well. So public, actually this should be double get balance, actually let's keep it integer so that it would look nice. So refactor, alright, I'll do it manually. Integer, and integer. Alright, we'll print out new balance. And let's put a $sign. So if this, then else. Not enough. Or let's say not enough. How can I say correctly? Your balance is red. I guess that's how you call this. Your balance is red. Not enough fonts. Alright. So now let's run our threads. So t1.start, t2.start, and then try t1.join and t2.join, and then catch interrupted exception, and in the end we'll print out the total balance, the final balance. Dot get balance, so account dot get balance and a $sign. And let's run this. So we withdraw 600 and then 400. So this was the first one. So 400 was executed first, and then 600, as you can see, and the balance is correct. But what if I would remove the synchronized? Now we should have some errors. No, we're lucky. Lucky again. race condition does not occur. Okay, let me keep the synchronized keyword, and as you can see, everything works correctly. And we can also see the thread, which thread is withdrawing. I forgot to add this. Let's print the message. System out thread dot current thread get name is withdrawing this much amount. Alright, and let's run this. So thread 1 is withdrawing 600, then thread 2 is withdrawing 400, and you can see the final balance. Alright, now let's move the next task. Create a class with a boolean running variable true by default. In one thread, do while running, and in the other thread, after 3 seconds, change running to false. Check if the first thread terminates. So let's create a class and call it variable, or let's say visibility problem. So variable visibility problem. So boolean running variable. So let's create a boolean private boolean let's say running true. So it's true by default. Right. And let's actually write it in the main method. I will take this and put into the main method. We have our boolean running. Let's take it out. Let it be a global variable. Now we create a thread. So thread T1 new thread, and we are asked to create a while loop while running. So while running, you can see the visibility problem. So I should put it here, or I could use, I guess, public static. Okay, so while running is true. So let's print some message. Thread dot current thread dot get name, and let's say running is running, and then after it finishes, we'll print out thread dot current thread dot get name has terminated. Alright, now let's create another thread. thread, T2, new thread. So what this thread will do is that after 3 seconds, so we put try thread dot sleep to 3 seconds. We're gonna change the running to false. Alright, and catch the interrupted exception. And we're done. Alright, now let's run our threads. T1 start, T2 start, and let's see. So as you can see, let me actually put this thread to a sleep, so it will print out is running every 1 second. So thread dot sleep for a second. Alright, and we should put it in the try catch block. Alright, now let's run this again. So 3 seconds passed, and it's terminated. Okay, let's run one more time. Interesting. Let's try to decrease the sleep time. Same. Alright. Alright, T1 join. T2 join. So that they would wait for each other. Surrounded by try catch block. And finally print out all the threads terminated. All the threads have terminated. Now let's see. We should have a visibility error actually. Let's assume that we have a visibility error, okay. And the next task, we are using the volatile keyword so that the thread exits gracefully after changing the variable. So we should have a volatile keywords. So this makes sure that this keyword volatile, it guarantees that the variable running will be directly written to the main memory instead of being stored locally in a cache. So in this case, we should always have the proper termination of our threads. So should run 3 times and then terminate. Okay, correct. Now let's move to the next task. Create an executor service with a fixed pool of 3 threads. run 10 tasks, each of which prints task completed and sleeps for 2 seconds. So executor service, so let's create a class. Let's call it executor service example. Alright, let's create a main method. So executor service allows us to create a thread, a pool of threads to manage multiple threads and be able to reuse them once we create them. So let's create an executor service. Then we can use executors dot, which one do we choose? Let's say new fixed thread pool. So we want to have 3 threads. So we pass number of threads 3, and we want to run 10 tasks. So 10 tasks. How can we do this? We can go to executor service, dot submit, and here we have our task. So executor service submit. So let's print out task. So task, let's create a task ID, integer, final task ID, which is equal to I, and we'll create a for loop here. So for integer I, which is equal to 1, I is less than or equal to 10 I plus plus, so we want to have 10 tasks running. Alright, so oops. So we have task ID, which is equal to I, final integer, and so here we say task with the ID. So task ID is started by then the thread name. So thread dot current thread dot get name. So task is started by the ID, then we go into try catch, try to put our thread to sleep for how much? 2 seconds. So 2 seconds, then catch interrupted exception, and it will run this loop for 10 times because we have I less than or equal to 10. And then in the end, what we're gonna do, we will shut down our executor service, so that the program finishes gracefully. Shut down. Alright. let's run this. Oh, we have an error. What error is that? Yes, we have problems with the braces. Alright, this is our for loop. Yes, now let's run this one more time. So task 1, task, woohoo. Task 3, task 2, task 5, task 4, 6, 7, 8, 9. So the behavior is unpredictable. Let's run this one more time. You can see task 2, 3, 1, 4, thread 2, thread 1, 2, and 3. So remember we have 3 threads. As you can see, 3 threads were running these processes. Alright, now let's move to the next task. So use shutdown and await termination to wait for all tasks to complete before exiting the program. I guess this was related to the previous problem. But yet let's use it anyway. So await termination. Executor dot await termination. And let's print out another message. So when it finishes, we say system out task with the task ID has been completed by our thread. So thread, current thread, get name. Alright, let's run this one more time. Semicolon expected. It cannot be applied. Alright. So this is a method of class executor service that takes a parameter long timeout and time unit. Alright, let me use this. Let's add a try catch block. Try this. Try if our await termination is longer than 15 seconds. So it's longer than 15 seconds, then time unit is in seconds. Alright. Then we'll call executor service dot shutdown. And print out forcing shutdown. Alright. And then we need to catch this. Catch. And in the end we can print out all tasks are have finished. And now let's run this. So task 1, 2, 3. Started, finished, started, finished. Started, finished. And the program took more than 15 seconds because we have 10 tasks, each of which takes 2 seconds. And as you can see, it forced shutdown and all tasks have been finished. Alright, and let's move to the next example. Create 3 executor services: new fixed thread pool, new cache thread pool, and new single thread executor, and run 5 tasks in each of them and compare the behavior. So let's create a new class. How do we call this? Let's call thread pools. Right, let's create a main method. So now we're asked to create new fixed thread pool, so it is the same executor service, let's call it executor, or how do we call this? Let's call it fixed pool. So executors dot new fixed thread pool of 3. Alright, cached. The next one is cached. So executor service cache pool. Let's say executors dot new cache thread pool. And one more, executor service, and this time single thread executor. Single thread executor. Let's call it single thread executors. And yes, we're done. Now let's run 5 tasks in each of them. So fixed pool dot submit, let me actually use a for loop before that. So for integer I is equal to 0, I less than 5, and I plus plus. Then we'll have our fixed pool submit. So submit. Let's make it print out task is running. Let me actually make it from 1 to 5, and we can use I as an ID for this. So plus I plus this. Now let me copy this, and I will do the same for cache pool, the same for single thread. So single thread. And let me say Actually, before this, I will print out cached pool, cached pool, like this. Let's print here fixed pool, fixed thread pool, cached thread pool, and single thread executor. Single thread executor. Like this. Alright. And let's put the new line so that we could clearly see the difference. Alright, let's run this. And also, we should shut down it before. Yes, almost forgot. So fixed pool shut down. Cache pool shut down. Single thread shut down. Now we can run this. Why so? All the tasks were executed in a single thread executor. Interesting. Let's change the variables to final. I guess that's the problem. And let's run this one more time. Okay. Let me use a try sleep block. So try thread.sleep for half second. I will take this and paste to all of my thread pools. Now let's run this. To see the difference, we should also mark the name of the thread. So thread dot current thread get name. Let me copy this. Now let's run this. Okay. So when we run this, we can see task 1 is running and it uses only 3 threads, so 1, 2, 3. And here in cache thread pool, it uses only 1 thread, but it's supposed to use unlimited number of threads for the cache thread pool. And for single thread, we have only 1 thread. So these are the differences between these 3 thread pools. Alright, now let's move to the next task. We're asked to create a callable that calculates the sum of numbers from 1 to 100 and returns the results. So use future and callable to get the result. So let's create a new class callable and future. So callable and future, they work in pairs. It's similar to runnable, but runnable has a return type void and it does not return any result. But with the pair callable and future, we can execute our tasks in the callable and get the result using the future class. So let's create a main method callable, and of course we need to import so our callable has a return type integer, so we say integer, let's call it sum. So like I said, it's similar to runnable, so we use the lambda and then write the task that we want to perform. So let's say we have let's create a for loop. So for integer I starting from 0 so from 1 to 100, so from 1 to 100 less than or equal to 100 I plus plus. Let's actually call this sum task, and so that I could create a variable of type integer and call it sum. So initialize it to 0, then we'll add I to our sum, and in the end we will return our sum. Alright, so this is our callable. Now let's create an executor service to manage our task. So executor service is like a manager, so let's call it executor. Let's call a single thread. And then we create a class, the future, also of type integer. So here we'll store our result. And what do? We take executor and submit our task, which is sum task. Alright. Then we get the result. So system out sum of integers from 1 to 100 is equal to result dot get. And of course we need to wrap this around the the exceptions. Let's just throw them to our main method, and we need to shut down the executor service. Shut down. Now let's run this. So as you can see, sum of integers from 1 to 100 is 5050. Let me check. Yes, that's a valid answer. It is indeed 5050. So let's move to the next task. Create 5 callable tasks, each returning a random number. Collect all the results using executor service. Run 5 callable tasks and get their results using invoke all. Let's create a new class. Let's call it multiple callables. So let's create a main method, main, and for this task we're gonna need an executor service. So executor service, let's call it executor. Then we use executors dot new fixed thread pool 5. So we need 5 threads. 5 threads. And we need random class also, random, new random. Now let's create a callable. So callable integer, and we actually want to have 5 callable tasks. So let's wrap this around a list. So list, let's call it tasks, new array list, and of course we need to import this. Alright, so now we have our callable. Let's create a for loop. So for integer I starting from 0 up to 5, and the step is 1. We want to create the tasks, right? How can we do this? It returns a random number. So we can go and take our executor, say, actually not the executor but the array, so tasks dot add right, then within to the arguments we're gonna pass the lambda expression. So we remember that the type of our list is callable, so we can use the lambda expression as an argument. So what do? We want to get a random number. Let's say some random number, actually no, we want to return random dot next integer. Alright, and you put semicolon, so it will generate 5 random numbers and it will return actually no, we're actually adding, we don't need to return any value, we can have it like this. So we generate 5 random numbers, then we add them to our list. Right, now let's create a future to be able to obtain the results. So future of type integer, and also wrap this around the list. So list, let's call it results. here we call the executor, and we invoke all the tasks. Alright, I guess we need to use a try-catch block. Let's actually wrap this around a try-catch block. So I will say try this, and then catch interrupted exception. Alright, and also we want to print out the results, so let's go and use a for loop for each future integer task in tasks. We will print out random number, then we will get the task dot get. Right, and also we need to have another exception, runtime exception. Can do it like this, runtime exception. And execution exception. Execution exception. What's wrong? Oh, I see. Our future is the result. So for each future result in results, we want to get the result. Alright, now we have an exception, interrupted exception, interrupted exception. So also let's add the bound for our integer. Let's say between 0 and 99, and we're good to go. Alright, and finally let's add a finally block that will execute regardless of the result. We'll shut down our executor. So shut down executor. Now let's run this. Building. As you can see, 5 tasks, random. Let's run one more time. And this time the values are different. Alright. Let's go to the next task. Create an atomic integer and use it in 2 threads that increment the value 1,000 times each. So let's create a new class. And let's call it safe counter. So for the safe counter, we will use atomic integer. So atomic integer is a thread safe operator that allows us to prevent the race conditions. So so atomic integer ensures that the operations performed by the threads are indivisible. So if one thread is incrementing the shared value, the shared variable, then the shared resource, then it will make sure that no race conditions will occur during the execution of that program. So it allows us to use multiple threads, and it guarantees the safe execution of the program. So let's create an atomic integer. Atomic integer of type, atomic integer, let's call it, how do we call this, counter. Alright, and create new atomic integer. And we need 2 threads. So let's create thread 1 and thread 2. Thread T1, new thread, and let's implement let's override its method run. So it should increment the value 1000 times. So it should take the counter. So let's say counter dot increment and get. And we want to perform this 1000 times, so we need to have a for loop, integer I from 0 to 1000. I++ is our step. Then we put semicolon here, and we want the exactly same thread. So I will just copy this and change the name to T2. Alright, now we have 2 identical threads. Now we need to start them. So T1 start, T2 start, then we will have joins. So try, so that if one thread finishes earlier than the other, they would wait for each other and we would get a correct final result. So try, catch, interrupted exception, and finally let's print out some message. Final value of counter. And we will put counter. Alright, looks good to me. Now let's run this. So as you can see, final value of counter, it's 2000 as expected. So we have 2 threads. One thread goes 1000 iterations and increments the value of the counter by 1000 times. Then comes the second thread and does the same, so increments the value of the atomic integer counter by 1000 times. They can do it concurrently, so these threads will run parallelly and no race conditions will occur thanks to the atomic integer. Now let's create an atomic integer with an initial value of 0. Use compare and set to update the variable if its current value is 0. So let's create a new class, I guess. Let's call it atomic integer. Make atomic int. Can we create an atomic integer? Let's just call it atomic, or let's say atomic integer example. Let's create a main method and create an atomic integer. So atomic integer, let's set its initial value to 0. What's wrong? And use compare and set to update the variable if its current value is 0. Actually, this is not how we create an atomic integer with initial value 0. We should say new atomic integer, then pass the initial value to the parentheses. Now we can use the method compare and set. So compare and set, if the initial value is 0, then we will set a new value, let's say 100. Alright. Now we can print out this. Let's say initial value atomic integer and final. There's a misspelling. Initial and final value. So now let's run this. As you can see, initial value is 0, final value is 100. Now let's move to the next task. Create 2 resources, lock1 and lock2. Run 2 threads where thread 1 acquires lock1 and then lock2. Thread 2 acquires lock2 and then lock1. So we will have a deadlock in this situation. Let's try it. Let's create a new class. Deadlock. Let's go and create a main method. Let me change the theme. So let's create locks. Lock. We can use a class lock to create locks. So lock1. New. Reintrant lock, and I need to import the class lock. Let me copy this and create lock2. So we have our resources, lock1 and lock2. Now let's create threads. So thread t1, new thread. So we want our thread to lock. So first thread 1 acquires lock1 and then lock2. So it takes lock1 and locks it. So lock1 lock. Let's print out thread 1 acquired lock1. So first it locks 1, then locks 2. Let's imitate some work and add it to add some sleep. So try thread dot sleep for half a second, then catch, interrupt the exception. Alright, then we want to lock the second resource, so lock 2, lock, and we'll print out thread 1 acquired lock 2. Alright. Let's also add sleep. So I will just copy this. And let's copy our thread since it's identical. The only difference is that we'll make it T2. So in the second thread we acquire lock 2 first, then lock 1. So let's change the lock 2 and then lock 1. I'll change lock 2, lock 1. Alright, now let's start our threads. So T1 dot start, T2 dot start. Now we can run this. So a deadlock should occur in this case. Not exactly a deadlock. To a deadlock to occur, we should unlock. We should unlock the lock 1. So let's unlock 1. Let's print out thread 1 unlocked. Unlocked lock 1. And the same for the second lock. Thread 1 unlocked lock 2. Alright. Let me take this and I will copy and paste it to our second thread. So here lock 2 unlock, it says thread 2 unlocked lock 2, and the same lock 1 unlock, thread 2 unlocked lock 1. So now we should have a perfect deadlock. Let's see what we got. Interesting. So I see this should be thread 2. try to. Now we can try to run this again. So as you can see, thread 1 acquired lock 1 and thread 2 acquired lock 2, and they're waiting for each other to free the locks so that they could acquire the locks. So thread 1 waits for the lock 2 to be freed by the thread 2, and thread 2 is waiting for thread 1 to free the lock 1. And so they're waiting for each other for an infinite amount of time, and a deadlock occurred in this case. In the next example, we're suggested to use a try lock instead of lock to prevent deadlock. And if a thread fails to acquire the second lock within 1 second, it must release the first lock. So we have some conditions. Let's try to fix that. So we can use try lock. Try lock. So we'll say try lock for 1 second. So time unit is seconds, and we'll wrap this around an if statement. So if this is true, only then it will go and lock the following. Following code. So can give an indentation. All right. And then we'll do the same for the lock 2. So try lock for 1 second, and time unit a second. And let's wrap this around an if statement. So if this is true, then it can go and execute this block of code. So try this. So if there are any, if this condition is not true, and if it will not be able to acquire the lock within 1 second, then we'll print out another message, and we will say thread 1 could not acquire lock 1. Like this. And then we try to lock the second resource. Yes, we try this, and if not, print out thread 1 could not acquire log 2. Let's change time to half a second, so we say half a second, and of course we should have a try catch block for the method try log. If we want to use try log, we should surround it with a try catch, since interrupted exceptions may occur. Alright, the same here. And finally, we will unlock, so this is log 2, we will unlock log 2, log 2 unlock, same here, so finally log 1 dot unlock. I will get rid of this and put this. Alright, so let's do the same for the second thread. So we go and put try lock, for 1 second, time unit, seconds, put this in an if statement, so if, and then we execute this part of the code. Alright, and so we add an else statement, so else I also print out thread 2, could not acquire, oops, pardon, should be in parentheses, in captions. Acquire thread 2 could not acquire a log 2, so log 2, right, and surround this with a try catch block, and then we go and do the same for our second lock, so if log 1 try lock, so try lock for a second, time units for seconds, and then we take this part of the code and we put an else statement. So let me just copy this and paste it here. And then we'll surround this with try catch block. And finally, so this is for lock 1, we need this one. And finally for this block, we'll take this one. And just like that. Alright, so now a deadlock should not occur. We can try to run and see what we got. So let's run. As you can see, thread 1, thread 2, they acquired lock 1 and lock 2, thread 2 unlocked lock 2, thread 2 acquired lock 1 again. No, thread 1 acquired lock 1, thread 2 acquired lock 1, thread 1 unlocked lock 1. So as you can see, and the program finished gracefully with no deadlock. As you can see, we have one. So thread 1 acquired lock 1, thread 1 unlocked lock 1, then thread 1 acquired lock 2 and unlocked lock 2. And you can see thread 2 acquired lock 2 and unlocked lock 2. Then again it acquired lock 1 and unlocked lock 1. So now let's move to the next task. Use try lock, that was the previous one. Now create a live lock situation where two threads try to avoid deadlock but end up yielding the resource to each other indefinitely. So this is a live lock situation. Let's create a new class with that name live lock. So in order to get the live lock, let's create two threads. So thread T1, new thread, and then thread T2, new thread. So how can we do this? So let's also create the locks. So lock 1, new return lock, and lock 2, new return lock. And of course we need to import the library, the package. Now let's define the logic. So let us lock 1. So let's lock 1. Lock 1. out thread 1 acquired lock 1, and we'll put it to sleep. So thread.sleep for half second, and wrap this with a surround with try catch block. And then we do the same for the second lock, so lock2.lock, and then print out thread 1 acquired lock2. Alright, and also we want to have all of this within an infinite loop, so while true, take and put this. Then again we put our thread to sleep for a half second after we acquired the lock2 and surround it with try catch. Alright, let's actually have all of them within one try catch block. So I will just take this and like this. So lock 1, thread sleep, and finally, so here, finally we'll unlock lock 1 and lock 2. Alright, so the same logic for the second thread, and in the end let's print out thread 1 finished its work. And let me just copy all of this. And I will paste it in our second thread. And let's actually change the order of the locks. I'll put lock 2 first, then lock 1, so that could create a live lock. And we'll release lock 1 first, and then lock 2. Alright, now we can start threads. T1.start, T2.start, and let's try to run this. So thread 1 acquired lock 1, thread 2 acquired lock 2, and they're both keep yielding the processor to each other without moving forward, creating a live lock in this situation. Actually, it looks like a deadlock. Let me change a little bit. Let's use a try lock. So let's say if lock 1 dot try lock sleeps. So if lock1 try lock is true, then we'll print out thread1 acquired lock1. Then we go for another if lock2 dot try lock. Then we go and print out thread1 acquired lock2. Alright. And we'll break out of the loop. So if the this part executes successfully, then we'll break out of the while loop. If not, then we'll print out thread1 could not acquire lock lock1 and releasing lock2. Alright, let me put the braces for this part, and we'll put it to sleep. So thread sleep for 100 milliseconds, and this is actually related to this part. Like this. So we forgot to unlock 2, so lock2 dot unlock. Alright, then we'll put the sleep and then handle the exception. Which we already handled here. So and we can remove the finally block, and let's do the same for the second thread. So I will just copy this. Just copy this part and paste it here. And let's change the order of locks. So first we'll lock 2, then lock 1. Now we can try to run this. So thread 2 acquired lock 2, thread 2 could not acquire lock 1 and releasing lock 2. Thread 1 acquired lock 1 and thread 1 acquired lock 2. Alright, so as you can see, we have a live lock here in this case. 2 threads, and they keep yielding the processor to each other without moving forward, so they keep making useless actions without moving the program forward. So now let's move to the next task. Design a system that downloads multiple files in parallel. Use executor service with fixed thread pool. Each thread should download 1 file. Simulating download via thread sleep. And after all downloads are complete, display the message, all files have been downloaded. So let's create a new class. Let's call it multi-threaded download system. Alright, so here we will create a main method and we're asked to use executor service, so let's create executor service. Let's call it executor and create a fixed thread pool. So called executors dot new fixed thread pool. And let's take 3 threads. And here so let me also create some constant variables. So let's say private static integer, let's call it thread pool size, and it's equal to 3. And one more, private static integer, this is for the number of files, let's say files. So we'll have 5 files. Let me also make them final. So these are the final values. Alright. So instead of 3, here I will use thread pool size. Alright. So we need to download, to simulate the downloading of files, right, and display the message all files have been downloaded in the end. So let's create a for loop for integer I, which is equal to 0. I is less than number of files, so files, and the step is 1, so go one by one. Alright, so here we use executor dot submit to start the execution of our threads. Then we use the lambda expression, and here we write the logic of our executor. So what do we want to do? We want to print out the message. Let's say file something, file I, started downloading. I think we need to create a new variable because we cannot access the variable I. So I will use here integer file ID, which is equal to I. Here we'll say file ID. Alright, so actually let me make it from 1 to files, so that we would have file 1, 2, 3, 4, 5. Started downloading, then we'll put this to sleep for some time, let's say 2 seconds. Yes, put this, surround this with try catch. And we're done. So it will go over the body of our executor submit 5 times, starting from 1 to files. File is 5, and it will use 3 threads. And in the end, we want to print out all files have been downloaded, right? And before that we need to shut down our executor. So executor shut down so that it does not accept any more tasks. Alright, now let's run this. So we have a problem. Let's see. As you can see, I put the shutdown within the for loop, so that was the reason why we're having this problem. Like that. Let me also add one more thing. I'll just copy this. File ID, download it. Like this. Alright, now let's try to run this one more time. As you can see, we have a problem again. Why this? Because we need to add one more if statement. So if executor dot await termination, let's use long dot max value. So this is the longest value, I mean the biggest number, and we will use for the time unit nanoseconds. Alright, and only after that we'll print out this message. So after all the processes have finished, then we'll print out this message. And we need to surround this with try catch block. Like this. Right, now let's run this again. So as you can see, file 1, 2, 3 started downloading, then it downloaded file 4, file 5, and we're done. Yes. And let's move to the next task. We're asked to develop a system in which customers or threads place orders and handlers, executor service, fulfill them. So we need to use a blocking queue to store orders. Buyers add orders to the queue. Processors take orders from the queue and process them. When all orders are processed, the program terminates. Let's create a new class that we'll call multi-threaded orders. Or let me actually call it blocking queue. Blocking queue. Alright. So let's create a blocking queue. Blocking queue. So we store orders. Let's say integer. So we'll store the ID of the orders. Let's say orders, new blocking queue. Alright. And we need to create a handler, so executor service. Executor service, so handler, handlers, executors. So what do we create? We create a thread pool, I guess. It's a new fixed thread pool. Let's say 3 handlers, and let's create our customers. So thread customers, new thread, and here we have our lambda expression. Right, and we will have a for loop. So for integer I from 0 to, let's say from 1 to 10. So we'll have 10 orders. Alright, and we'll print out order I is added to queue. Then we will take the order and put it to our blocking queue. So orders dot put, let it be I. So order 1, order 2, order 3, and etc. And of course we need to put a try catch block. And we'll put our thread to sleep to imitate the order, let's say half a second. And let's actually say customer placed order something, order 1, order 2, and etc. Alright, it. And then what we're gonna do now? Now we need the handlers to process the orders. So let me actually create the constants so that we could clearly see. So private, static, final. So we have how many handlers, how many customers, and how many orders. So number of orders, or let's say total orders. So we have totally 10 orders. Yes, it's integer, and then we'll have number of handlers, these are our threads, so 3, and number of customers, let it be 5. So now we can put here, instead of 3 number of handlers, here we'll put total orders. Then when we start handling our orders, we use executor service or handlers submit, and before that we need to use a for loop. So for integer I, which is equal to from 0 to the number of handlers, we'll take our submit, and here we have our lambda expression. So in the body, what do we have? So now we have a try block, try infinite loop, while true. We want to have the orders, so we want to process the orders. We take orders dot poll timeout, so it waits 5 seconds, time unit seconds. So let's assign it to some integer, order ID, yes, and then we'll add some condition. So if the order ID is null, then it means that all the tasks have been processed and we need to break out of this loop. We have a misspelling, order ID. Alright, if not, then we imitate that we process the order. So order ID started, or let's say started processing order number something. Then we imitate the sleep, so sleep for 2 seconds. Then we say order completed. Order something, order ID, completed. Alright, then we catch the exception. Catch exception. Actually, we should have an interrupted exception here. Interrupted exception. Then e dot let's interrupt the thread. So interrupt thread, interrupt thread, current interrupt. If something goes wrong, we interrupt the thread. Right. And now we can start our program. We can start customers dot start. And also we need to shut down the executor, so handlers, and let's make our customers join so that the threads wait for each other. Let's surround it with try catch block and shut down the executor service. Handlers shut down. Alright, now let's run this. Java cannot infer. Instead of array, let me make it linked blocking queue. Now it should work. Let's run this one more time. So as you can see, customer placed order 1. The order 1 started processing, then it placed order 2, order 3, 4, order 5, order 6, 7, 8, 9, and 10 orders. And you can see it just prints every time order completed. Order 6 completed, 7, 8, 9, 10, yes. So everything works correctly. Now let's move to the next one. Develop a service that updates the data in the database once in a minute. Use scheduled executor service to automatically run the update task. Each run must be performed in a separate thread. Simulate work with the database using the thread sleep, and the program should run 5 minutes and then terminate. So let's create a new class, data update system data update system. So we need to use scheduled executor service. So let's go and do this. Scheduled executor service. Let's call it executor. So we use new scheduled thread pool. Just one is enough. Now let's use runnable to create a lambda expression. So update task, that's how we're gonna call this. So we'll print out message database is updating. Then we'll put thread to sleep, so thread.sleep for 2 seconds, and then we'll print out date. We'll print out update completed. Right, and then we need to surround this by the try catch block. So try catch. Alright. So now we have our function. Now let's use scheduled future to update our task, our database every minute. So we use a wildcard since we don't know what type of this will be. Let's call it scheduler. Actually, let's call it scheduled future. And here we'll call our executor dot schedule at fixed rate. And then we'll input our runnable command, so update task. Alright. So let's say from 0 to 1 minute. So 1 time unit minutes. Alright. And let's shut down our scheduler. So executor dot shutdown. Actually, let me keep this. Before we need to execute, executor dot schedule. So schedule. So here we create our lambda expression. So we'll make scheduled future cancel may interrupt if running false. And then we have our executor shutdown. Then we'll print out scheduler shut down after after 5 minutes. Or let's say terminated. This is service terminated after 5 minutes. And then we will put 5 and time unit is minutes. Alright. Now we can try to run this. see the results. So database is updating, update completed. And after 5 minutes it will shut down. Let me actually change this. I will put 5 seconds. So after 5 seconds, actually we want it to update every minute, so let's actually wait 5 minutes. Let's run this and wait. I will pause the video and I'll continue after a minute. So what this is gonna do, it's gonna update our database every minute, and the update takes 2 seconds, and it will do this for 5 minutes. For 5 minutes, and after 5 minutes it will terminate. So this is the logic behind this program. So 2 minutes passed. Let's wait for another one and I will terminate it and we'll move to the next task. So another minute. Alright, as you can see, update completed. So you get the logic, right? Let's move to the next task. Next task is we're asked to create a warehouse system where 5 workers load goods, and after they're done, a truck or a thread can leave. Use countdown latch to make truck wait until all workers have finished loading. Workers perform loading, and after all threads have completed their work, the truck displays truck is leaving. So we need to use countdown latch. Let's create a new class, warehouse system. I'll create a main method. So let's create a countdown latch. Countdown latch. Let's call it latch. New countdown latch. So we have 5 workers. Right, so that's why we keep 5. Then we go and create a for loop, so for integer I starting from 1 up to 5, less than or equal to 5, increment I by 1. Now let's declare a variable of type integer. I will say worker ID. I will set I equal to worker ID. Worker ID equal to I, so that we could print out the ID of the worker. Now we have a try block, so try new thread. So we need to create a thread or workers. So So we create our workers and we print out worker with the ID, worker ID, started loading goods. Then we put the thread to sleep, so sleep for 2 seconds, and then print out worker with the worker ID something, finished loading. Alright, and now we need to have a try catch block for our sleep. So let's move this inside. Alright. And finally we decrement the latch countdown, so latch dot countdown. It decrements the count of the latch, as you can see. So, and we can directly call the start method from here. Alright. Then what do? We make our latch to wait until all the workers finish loading, and of course we need to surround with try catch block, latch await, and then print message truck is leaving. So after threads have completed their work, we need to print out truck is leaving. Alright. Now let's run this method, this program, and you can see workers started loading, then they finished loading, all of them finished, and only then truck left. Alright. And the last task is develop a program that sums the elements of a large array using fork join. Fork join allows us to run the tasks in parallel. To break the tasks into subtasks. So we're asked to split the array into pieces. If the length of the part is greater than 10, recursively break it into sub-problems. If the length is 10 or less, perform summation, and in the end collect and withdraw the final amount. So let's create a new method. Parallel array sum. This is the last class for today. So we need to use a fork join pool. So let's create a main method. Let's use fork join pool. Fork join pool. What methods does it have? Alright. So let's call it pool. New fork join pool. And we need an array. So let's create create integer array, new integer with 1000 elements, 1000 numbers, and we'll put numbers from 1 to 1000 to our array. So integer I starting from 1 go up to 1000 and increment by 1. So we'll take our array, actually the indices should be from 0 to 999. So we take array index of I plus equal I plus 1 because we want to add want to start the adding numbers from 1, not from 0, so that's why I add 1 here. Alright. So now what we're asked to do is we're going to develop a program that sums elements. So split the array into pieces if the length of a part is greater than 10. So let's create another class. So let's create another class. Let it be inside our main class. So it will be a static class. Let's call it some task. We need to extend the class recursive task, and the type will be long. So as you can see, recursive task is an abstract class that extends fork join, and we need to override the compute method. So let's go and do that. As you can see, it asks us to implement the method compute. So we'll go and override this method. But first, let's declare some fields. Private integer array. So array. Then we need start and endpoint. So private integer start and private integer end. Now we need a constructor that takes all these parameters. So let's create a constructor. So we remember the name of the constructor matches with the name of the class. So we take some task and we say we ask for the array. So integer array, integer start, and integer end. Alright, and then we take this dot array is equal to array. Then we take this dot start is equal to start, and this end equals to end. So this is our constructor. Now let's go to our method compute. So we need to override this method, and so we split the array. we split the task into subtask if the length of the array is less than 10. So we take if the end is, the end minus start, so this will be the length. If it is greater than 10, then it means we need to divide that into subtasks, and we take integer mid is equal to start plus end divide by 2, so we get the midpoint. Then we call our sum task recursively, so sum task, let's call it left task is equal to new sum task, and we pass our array start and end. And another one, sum task for the right one, right task. We create a new sum task. We call the we call the tasks recursively. So in this case, we pass array, and the start will be midpoint because we divided our task into 2 subtasks, and end is the same. Alright, now what do? We go to left task and right task. So left task dot fork, so we execute them in parallel, and we go right task dot fork, and then we need to collect the result. So we take long left, let's say left result is equal to left task join. So we collect the results, and we go long right result of the right task. We take right task dot join, and we return the sum of these results. So we return left result plus right result. Alright, this is in case our array is greater than 10. The length of the array is greater than 10. If it's not greater than 10, then what we will do, we need to get the summation. So if the length is less than 10, we need to sum all the elements from the array. So we go and declare a variable sum. So sum, then we iterate over each element, so integer I, which is equal to start, starting from I, going up to the end. So I is less than end, and then we go I plus plus, so the step is 1. Then we say sum plus or equal to I, actually array I. So we add each element of the array and store it in the sum variable. Then after the calculations are completed, we return the sum. Alright, so this is our static class sum task. Now we can go to our main method and let's call our sum task. some task. Let's say task. Let's create a new some task, and we need to pass our array. So we have already created our array. The start will be 0 and the end will be the length of our array. So array.length. Alright. Now let's declare a variable result. So long result is equal to, we have our pool, so fork join pool. We can call the method invoke the task. Right, and in the end we can print out the result, sum of all elements, sum of numbers from 1 to 1000, so that is our array, will be the result that we obtain from this calculation. Now let's go and run this. Oh, we have an error here. Looks like Stack Overflow. So the issue is in our left task. So the end should be mid, not the end. Should go until mid, because we divide the array from start to mid. We don't take the full array here for the left task, and in the right task we start from mid where we left and go till the end. So now let's run our program again. So as you can see, sum of numbers from 1 to 1000 is 500,500, which is correct. Alright, thank you for watching. This was the last task, hopefully. Yes.